Good morning, students. In 9th standard, last period, we learned about theorem of 45 degree and 90 degree angle. Is the statement of the theorem is if the measures of angles of a triangle are 45, 90 degree, then length of each side containing the right angle is 1 by root 2 into hypotenuse. Then next we have see property of median drawn on the hypotenuse of a right angle. We have see one activity. Then theorem of this point is statement of the theorem is if a right angle triangle, if a right angle triangle, the length of median of the hypotenuse, the length of median of hypotenuse is half of length of hypotenuse. Is half of length of hypotenuse. Length of hypotenuse. Statement of the theorem is in a right angle triangle, the length of the median of hypotenuse is half of the length of hypotenuse. Firstly, we have to draw one right angle triangle. ABC is a right angle triangle. BD is the median of right angle triangle. Then extend BD is median of right angle triangle. Then extend BD. Then we have given one right angle triangle. Then firstly we write given of the theorem. Given is in triangle ABC, angle B is equal to 90 degree. This angle B is equal to 90 degree. Segment BD is a median. Segment BD is median. given. To prove, we have to prove BD is equal to 1 half is median is equal to 1 half into hypotenuse, 1 half AC. Then proof of construction is, what's the right construction of this theorem is, take point E on the ray BD, take point E on ray BD, take point E on the ray BD such that B, D and E are collinear. Construction is take point E on the ray BD such that B, D are collinear. Draw, and length of BD is equal to length of DE length of BD is equal to length of DE, and draw segment is, this is construction of the theorem. Then proof of the theorem is, triangle ADB is congruent to triangle CDE by side angle test. Then line AB parallel to line EC by test of alternate angle. Angles. Next one is triangle ABC is congruent to triangle ECB by side angle side test. Then BD is equal to 1 half AC. Triangle ABC is congruent to triangle ECB. Then by side angles and BD is equal to 1 half AC. We have given one main steps in, then we have to write the proof of the theorem. BD is equal to 1 half AC. The next one is perpendicular bisector. Before starting this theorem, we have given one activity. We have given one note. In a right angle triangle, the length of median on its hypotenuse. We have seen the theorem. We have given one note. In a right angle triangle, the length of the median on its hypotenuse is half the length of the hypotenuse. Then next one, we have given one activity. Activity is notice. Activity: draw segment AB on convenient length. Label its midpoint as a M. Draw one segment AB. Next one is of conveniently any length. Label its midpoint. Midpoint of AB is M. Draw a line passing through the midpoint and perpendicular to segment AB. Draw a line passing through the midpoint of AB. Line here is and perpendicular to segment AB. Did you notice that the line L is a bisector of segment AB? Line L is bisector of segment AB. Line L is bisect the segment AB to at point M. Now take a point P anywhere on line. Take one point P on line L of anywhere. Compare the distance PA and PB. Compare the distance PA and PB with the divider. What did you find? You should have noticed that PA is equal to PB. We have noticed that PA is equal to PB. This observation shows that any point on the perpendicular bisector of a segment is equidistant from its end points. This observation says that any point on the perpendicular bisector. In this diagram, we take a point P is a perpendicular bisector of segment AB. Segment is equidistant from its end point. Is equidistant from its the distance PA and distance PB is PA is equal to PB. Now with the help of compass, take any 2 points like C and D which are equidistant from A and B. Take second points D and C and D. Take points with the help of compass. Take any 2 points C and point D equidistant, which are equidistant from A and B. Did all such points lie on the line L? What did you notice from the observation? What did you notice from the observation? Any point of equidistance from the end points of the segment lies on the perpendicular bisector of the segment. These two properties are two parts of the perpendicular bisector theorem. These two properties are first property, point P is equidistant from end points of the segment. Then next we have take any 2 point with the help of compass on the perpendicular. Then this is also equidistant from end points of the segment. These two properties are two parts of perpendicular bisector theorem. Let us now prove them. Then our next point is perpendicular bisector theorem. Then 2 parts are given, part 1 and part 2. Then firstly we see the first statement of the part. First is we have C only statement. Like in next figure we see the proof of the part first. Perpendicular bisector theorem. Perpendicular bisector theorem. The statement of the theorem is part first. Every point on the perpendicular bisector of a segment is equidistant from endpoints of the segment. Every point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. Every point on the perpendicular bisector of a segment is equidistant from endpoints of segment. Endpoints segment. Every point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. This is statement of perpendicular bisector theorem part 1. We have seen proof of this theorem in next period. Okay, thank you.